Welcome all. Today we are going to discuss about oxidation state of chromium complexes. Chromium complex, as already we discussed other transition metal like scandium, titanium, vanadium in the previous video. Next element of our discussion is chromium. This is the next element to your vanadium. Here the atomic number of chromium is 24. Here the configuration is a little bit different from the regular trend. Actually, configuration of vanadium is atomic number 23, is a group number 5. So hence we have the 3D3 4s2. As per this trend, we have to, given the atomic number for chromium, the configuration should be 3D4 4s2. This is our expected configuration, but actually that configuration is something different to attain the stability of your chromium concept. So that expected one is here. The correct electronic configuration of chromium is that electron from porous orbital is shifted to 3d5 and we will get a 3d5 porous one. Here only the s orbital is stable. The 3d4 there is a partially filled orbital. Here less stability. To attain the stability, one of the s orbital is transferred to d orbital. Now this is half filled and this is half filled. So both the orbitals are half filled. Hence the stability is something higher than that of the expected configuration. So the correct d electron configuration for this chromium is 3d5 4s1. Argon 80, 3d5 4s1. This is correct electronic configuration for this chromium to attain stability. Chromium shows various electronic state, that multiple oxidation state which is shown. Chromium 2+, chromium 3+, chromium 4+, chromium 5+, chromium 6+. So chromium 2+, what it will be happen? One s electron is removed. Therefore, we will get a D4 configuration. Chromium 3, actually the family number is the 6th family. 3 electron is removed, we will get D3. Chromium 4, D2. Chromium 5, D1. Chromium 6, D0. This is example for this complexes, potassium dichromate, K2Cr2, O7. In K2Cr2O4 also, we will have the example for this complexes. Now we will going to discuss as usual one neutral ligand, one charged ligand, one bidentate neutral ligand, one bidentate charged ligand, and one multidentate ligand. As I said earlier, we will have take an example as chromium water complex. CrH2O 6 times 2 plus, CrH2O 4 times 3 plus, CrH2O 6 times 3 plus, CrH2O 6 times 4 plus. So consider, I am just to take water as an example. Any neutral monodentate ligand that shows the same trend. So here the ligand is neutral ligand, hence the complex is cationic complex. So if the complex is cationic complex means, so it should be like this: CrH2O 6 times 2 plus. So it may be Cl2 or CrH2O 6 times SO4 like this. So any di-negative you can add here. So here chromium X, water neutral ligand, 0 contribution is equal to +2. So chromium in +2 oxidation state. Chromium 6th family, you can remove 2 electrons. So we will have D4 configuration. Chromium in 2+ oxidation state. Here and tetrahedral complex 4, chromium 3+. So X ligand contribution 0 is equal to 3. X is equal to 3. Therefore, chromium in +3 oxidation state. Chromium 3+ oxidation state means chromium is the 6th family. So remove 3 electrons. We will have D3 configuration. CrH2O 6 times 3 plus, chromium is taken as X. Water 6 ligand, 6 water ligand. It's octahedral complex. Contribution is 0. So we will have +3. So chromium in +3 oxidation state. Chromium in 3+ oxidation state means you can have the chromium 6th family, remove 3 electrons, you will get a D3 configuration. Chromium 4 plus X water 0 is equal to 4 plus X is equal to plus 4. Therefore, chromium in plus 4 oxidation state. Chromium plus 4 oxidation state means it is a sixth family. Remove 4 electron. Therefore, we will get a D2 configuration. Suppose I am taking an example as a CrH2O 6 times Cl2. So chromium as X, water ligand contribution 0, minus 2 is equal to 0, X is equal to plus 2. Chromium in plus 2 oxidation state, sixth family, remove the electron, we will have D4. So any neutral ligand follow this trend. Next we will go with one monodentate negative charge. Here monodentate negative charge, I take it as cyanido as an example. So Cr, Cn 4 times 2 minus. Cr, Cn 6 times 4 minus. Cr, Cn 6 times 3 minus. I'll give the probability chances. The chances are there. K3, Cr, Cn 6 times. This is anionic ligand, hence we have to put a cation here. So now chromium, I don't know the oxidation state of chromium, put X. One cyanido has a minus 1 charge, so 4 into minus 1. So we will have the minus 4 is equal to minus 2. Any charge we have to put in equal. So X minus 4 is equal to minus 2. X is equal to minus 2 plus 4 is equal to plus 2. Chromium in plus 2 oxidation state. Chromium 6th family, if you remove 2 electron, you will have the D4 configuration. Chromium Cn6 4 minus chromium X, each cyanido has minus 1 contribution. So therefore plus 4 into minus, sorry, here 6. 6 into minus 1 equal to minus 4. X minus 6 is equal to minus 4. X is equal to minus 4 plus 6 is equal to plus 2 configuration. Chromium in 2 plus oxidation state. Chromium 6th family. Remove 2 electron. You will have the D4 configuration. Here potassium has alkali metal, it has a positive charge plus 1. So 3 into plus 1, we will have the plus 3. Chromium will take it as X and the cyanido contribution minus 1, 6 into minus 1 equal to 0. So 3 plus X minus 6 is equal to 0. X minus 3 is equal to 0. X is equal to plus 3. Therefore, chromium in 3 plus oxidation state, 6th family, remove 3 electron. Therefore, D3 configuration. Cr cyanido complexes 3 minus. Chromium take it as X. Each cyanido carries minus 1. Therefore, 6 into minus 1 is equal to minus 3. X minus 6 is equal to minus 3. X is equal to minus 3 plus 6 is equal to plus 3. Chromium in 3 plus oxidation state. Chromium 6th family, remove 3 electron. We have the D3 configuration. So, any negative ligand, you can show this type of contribution. Negative ligand, especially monodentate negative ligand. Now we will go to bidentate neutral and bidentate negative ligand. Bidentate neutral, I take it as a ethylene diamine as example. CREN twice 2 plus. It's a neutral ligand, so complex may be your cationic complex. CREN thrice. So it is a hexadentate, and this is a bidentate ligand. So 2 means 4 coordination number. Here ethylene diamine bidentate ligand. 3 ethylene diamine means 6 coordination cycle. So maybe I will give the 3 plus. So chromium X ethylene diamine 0 contribution is equal to 2 plus. So chromium in plus 2 oxidation state. Chromium 6th family, remove 2 electron, we will have D4. Chromium 3 plus, here X En 0 contribution is a plus 3. So chromium in 3 plus oxidation state. Chromium 6th family, remove 3 electron, we have D3 configuration. I move for oxalate. Oxalate is a bidentate ligand, has a negative charge minus 2. So I will put chromium oxalate twice. Oxalate twice means is a 4 coordination site. So chromium X, each oxalate contributes minus 2. This is equal to X is equal to minus 4. I can modify the oxidation state as like minus 2 I will put here. So I will give minus 2. So X is equal to minus 2 plus 4 is equal to X is equal to plus 2 oxidation state. Chromium in 2 plus oxidation state. Chromium 6th family, remove 2 electrons. So we will have D4. By this way, I can chromium twice. I will modify this charges as like this. Chromium X. So each oxalate contribution 2. So 2 into minus 2, we will have the minus 4. Minus 4. So I will make this as minus 3. So what it will be happen? Minus 3, x is equal to minus 3 plus 4, you will have a plus 1 oxidation state. So chromium in plus 1 oxidation state, so D5 configuration. Suppose I just modify like this, chromium oxalate to 2, instead of minus 3, I will get minus 4. So x is equal x minus 4 is equal to minus 4. So x is equal to minus 4 plus 4 is equal to 0. So I can modify that oxidation state by varying the charges. By this way, you can modify. You can write your own complexes like what you are like. Okay, so this is bidentate ligand and one multidentate ligand as EDTA minus 4 charges. So chromium EDTA, 1 EDTA, it's a hexadentate ligand. So x minus 4 is equal to, so what I will give here, minus 2 I will put is equal to minus 2. So x is equal to minus 2 plus 4 is equal to plus 2 oxidation state. Here chromium is in plus 2 oxidation state. Chromium 6th family, remove 2 electron, you will have the D4 configuration. So any ligand you can you have to add that particular charges and you will find the oxidation state of that particular metal ion correctively. And you can see the previous videos for scandium, titanium, vanadium, and you will get an idea of how to write a complex of your own. What are the things, what you are thinking in your mind, you can write the complexes of your own. This is just an imagination only. Whether the complex is formed or not, this is nothing our business. Whether it is, we have to found the oxidation state and deconfiguration. For practice, you can make any complexes by using any ligand and any charges and make your own. Okay. So in the next video, we will see the next element to type chromium is manganese. So next video, we will discuss the oxidation state for manganese. Thank you so much.